Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss properties of thermal radiation. Let's begin. We know the mode of transfer of heat are three in number. One is conduction, another one is convection, last one is radiation. So what is conduction? Let an example. When we consider an iron rod and that iron rod is subjected to a fire source and the another end by our hand, then we feel heat at that of end at which we catch by our hand. So that process of transfer of heat is called conduction. Next, convection. The example of convection, if we consider a water top and water in that of top and that top is subjected to fire, the bottom of that of top where water is subjected or where water we taken are subjected to a fire source, means heat is implemented through the bottom of that of water top. If we observe the upper water level, then it seems to be heated, means heat flow from that of lower end to that of upper end. That is an example of convection. Last one, the mode of transfer of heat, that is radiation. Here we discuss about thermal radiation. What is radiation? The mode of transfer of heat in which heat travels from one body to another without the need of any intervening medium is called radiation. For the propagation of heat from one body to another without need of any medium, the phenomenon of heat transfer is called radiation. A best example of such radiation, the heat from sun reaches to earth by the phenomenon of radiation. Here we discuss various properties of such thermal radiation. Properties of thermal radiations. Thermal radiation is electromagnetic radiation. That is an important point. Thermal radiation is electromagnetic radiation that produced by thermal motion of charged particles in matter. In matter there are charged particles. Due to that movement of these charged particles, the thermal radiation executed, and that thermal radiation is under electromagnetic radiation. As we know, electromagnetic radiations have the properties as these type of radiations are propagated along straight line, means rectilinear propagation of electromagnetic waves, and the velocity of that electromagnetic wave is equal to the velocity of light. So due to their electromagnetic nature, thermal radiation travels through vacuum with the velocity of light. Next, the wavelength of thermal radiation ranges from 8000 angstrom to 0.4 millimeter. That range is the range of infrared. That range lies in the infrared region of electromagnetic spectrum. So we can say the wavelength of thermal radiation is infrared region. The thermal radiation travel in straight line. They travel in straight line, as this type of radiations are under electromagnetic radiation. So it is show the properties of electromagnetic waves or electromagnetic radiations. For the propagation of electromagnetic radiation, we don't have any kind of medium. Therefore, we write it the propagation of such kind of heat, they need of any intervening medium. Just like that of light, thermal radiation obeys the laws of reflection and refraction and exhibit the phenomenon of interference, diffraction and polarization like light. As we say, light is also an electromagnetic wave. Like similar to that of light, such thermal radiations also obey the laws of reflection, refraction and the phenomenon like interference, diffraction, polarization. Okay. Next, thermal radiations are unable to be detected by human eye. These are unable to be detected by human eye. As thermal radiations obey the laws similar to that of light, but light we see in that of visible range of electromagnetic spectrum, but thermal radiations are under that of infrared region. That is the basic difference between light as well as thermal radiations. Due to that infrared properties of that kind of radiations, we can't see by our naked eye. Thermal radiations are unable to be detected by human eye. Next point, which are those instruments by which we can measure the thermal radiations. Thermal radiations are detected by bolometer. That bolometer acts by using the principle as the change in electrical resistance with temperature. How electrical resistance is changed with respect to that of temperature, on that basis that instrument bolometer acted, and by using that bolometer we can easily detect thermal radiations. Or another instrument which is thermopile. Thermopile, which is the combination, that is the series combination of thermocouples. Thermocouples are connected in series and we form a device which is called thermopile, and by using that thermopile we easily detect that type of radiations, and that instruments are based upon the principle as the change of electrical resistance with temperature. How electrical resistances are changed with respect to temperature, that be the principle on which these devices are acted, and by using these devices we can easily detect that type of radiations. Next property, thermal radiations execute pressure on that of surface of material. When thermal radiations are incident on a material, such type of radiations execute pressure on that of material. They execute pressure on the surface of the material. Next point, when thermal radiations falls on a body like that of light, some portions means they are partly reflected, some are absorbed and some are transmitted, and the measurement of such reflection, absorption and transmission are measured by the term. As a term we define reflectance. Reflectance, that is capital R by Q, whereas capital R is the amount of thermal radiations reflected by a body in a certain time. Capital Q is the amount of thermal radiations falling upon that body in the same time. So the ratio of capital R divided by capital Q is the reflectance. Next, absorptance, it is the measure of capital A divided by capital Q. So capital A is the amount of thermal radiations absorbed in that body. Here I write capital A, amount of thermal radiation absorbed by a body in a certain time. Next, transmittance small t, that is capital T by Q, whereas capital T is the amount of thermal radiation transmitted by a body in a certain time. So these are some basic terms. By using that terms, we can easily show what be the amount of thermal radiations reflected, absorbed and transmitted. So reflectance, absorptance and transmittance depend upon the nature of the surface of a body. These depend on the nature of the surface of the body, and the coefficient of, that is reflectance, absorptance and transmittance is equal to 1. The sum of reflectance, absorptance, transmittance will be 1. So here with the help of this video lecture we understand the concept of properties of thermal radiation. What is thermal radiation? This is one mode of heat transfer. Example of thermal radiation and various properties. It is an electromagnetic radiation, so it follow the nature of electromagnetic wave. It is infrared, travel in straight line. Just like light, they obey various laws and phenomena. Due to infrared region, they are not able to detect by human eye, and they are detected by bolometer and the thermopile, on which principle these two instruments acted. Also execute pressure on the surface of the metal. So for thermal radiations, it's partly reflected, absorbed and transmitted when fall on a body, and its measure is reflectance, absorptance and transmittance. They depend on the nature of the surface of that of body, these three terms, and sum of these three are 1. So with this useful and informative notes, let me wind up the session. Thank you.